Hello, welcome to this video. We're going to be looking at graphing parent functions. This is a video intended for students in pre-calculus, both 30S and 40S. In the 30S, you're going to be learning about these functions for the first time, and in the 40S, these are expected to be review. You should pretty much already know how to graph these functions at the beginning of the 40S course. You need to know how to graph these basic functions so that you can learn about transformations, which you'll start learning about in the 30S pre-cal and then learn about in more detail in the 40S. So we're going to start with graphing y equals x squared. I'm going to make a table of values to show you where some of the values come from and the shape of this graph comes from. The recommendation, and I'm sure your teacher will echo this statement, you shouldn't be making a table of values every time you need to graph this equation or this function. You should pretty much just be heading to a graph and putting in the default points and then graphing the function. But for the first time, we'll use a table of values to help us. So I'm going to pick some values for x, plug them into this little equation and figure out values for y. I'm going to start with an x of 0. When x is 0, I put a 0 in here. 0 squared is 0. So when x is 0, y is 0. That corresponds to the point on the graph 0, 0. So let's put that point on there right now. Coming back to this one, we get let's pick an x of 1. 1 squared is 1. So when x is 1, y is also 1. So I'm going to come over here and I'm going to put that on our graph. And then when x is 2, 2 squared is 4. So let's put that on here, x of 2, y of 4. When x is 3, y is going to be 9, since 3 squared is 9. I'm not going to have room on this graph to show the point 3, 9, so I'm not going to go that high. I'm going to go a little negative. Let's look at negative 1. When I put negative 1 into the equation, I get y equals. Remember, every time you substitute a number into an equation, it should be in brackets. So I get negative 1 all squared, which is going to give me a y of positive 1. That creates this point right here at an x of negative 1 and a y of positive 1. And then at negative 2 all squared is 4. So at an x of negative 2, I'm going to get positive 4. And again, if I went to negative 3, I would get 9. If I went to negative 4, I'd get 16. I don't have room to put these on this graph, so I'll just stop there. These 5 points for most teachers are sufficient to draw a good graph of y equals x squared. The shape is called a parabola. This graph is parabolic. And I'm going to let the computer draw the rest of the graph, so I'm just going to jump in and I'm going to tell it I would like to see y equals x squared. Looks a little weird up here, looks a little more natural down here. And when I say OK, there's my graph, y equals x squared. You see a nice parabolic shape. Again, hopefully you've seen this graph already, that you've gone through with your teacher and seen it. And if this is the first time, that's fine. You'll get lots of practice with this shape as you go. Okay, so we are going to I'm just going to make a new file here, say no, I don't want to save my changes. Okay, and then we're going to try this again. Let me just go in here. Okay. The next parent graph we're going to take a look at is y equals the square root of x. Again, I'm going to start with a table of values, x and y. Now we have a problem here. I can't pick negative values for x. If x is negative 1, I get the square root of negative 1, and the square root of any negative number is undefined. You cannot square root a negative number. You get undefined. So there is no point to picking negative numbers for x. You're not going to see any graph for y equals the square root of x on the left-hand side of the y-axis, because that's all negative x values, which can't be square rooted. So we'll start at an x value of 0. I plug that in. Square root of 0 is 0. So that's the point 0, 0 again. I'm going to come and put that on my graph. Coming back when x is 1, square root of 1 is 1. So we get the point 1, 1. Right now we're looking like y equals x squared a little bit. For the next value I could pick 2. The problem with picking 2 is I get the square root of 2, which is approximately 1.41, but that is a decimal number that keeps going. It's hard to put that point exactly in the right place on here. I'll give it a shot. Right about there is 1.4. When I graph this function, you'll see exactly where it should be. The next x value I should have picked maybe is a perfect square, so I'm going to pick 4. Square root of 4 is 2, so I'm going to go to 4 here, and I'm going to get 2. You'll notice this kind of looks like the reverse of x squared. There's a reason for that your teacher will eventually get into. And we get those 3 points. If I picked 9, our next perfect square, square root of 9 would be 3. Yeah, I don't have an x of 9 shown on this graph, so I'm not going to bother trying to graph that point. So again, I'm going to let the computer draw the rest of y equals the square root of x. Looks a little weird on top, up here. But down here, it looks like what we're trying to graph. And I press OK. You can see I was pretty close with that point right there. It says I'm at about 1.4, right? And you get what looks like half a parabola arm facing sideways for the parent graph of y equals square root of x. Now, I should have said this with the last graph, but if you'd like, you could pause the video at any point and jot these down, put it on graph paper. You are going to need to be able to create these parent graphs on your own. The next graph I'm going to look at is the absolute value of x. Again, if you're in the 30S pre-cal, you may or may not have seen this yet, depending on the point of the course. If you haven't seen absolute value, you don't know what absolute value is, skip this part for now. You can always come back to this video when you get there. We're going to do another table of values. Okay, and I'm going to come back over here, and I'm just going to make a new file. So we have a nice clean graph ready for us. Okay, here we go. So if I pick an x of 0, absolute value of 0 is 0. This point's getting familiar. So I have a point at, 0, 0. Next, I'm going to pick an x of 1. Absolute value of 1 is 1. So I get a point here. Next, I'll pick an x of 2. Absolute value of 2 is 2. So I get a point here. Okay. And it continues on. Absolute value of 3 is 3. Absolute value of 4 is 4, and so on. You're going to get dots all the way up this diagonal line. I'm going to go negative. I pick an x of negative 1. Absolute value turns negatives positive. Okay, negative numbers positive to be specific. So negative 1 becomes positive 1 when it's absolute valued. That creates this point right here. Negative 2 becomes positive 2. That creates this point right here. And then same thing, negative 3, absolute value becomes 3. Negative 4 becomes 4. You're going to get a graph that is not a nice smooth curve like a parabola. And again, I'm going to let the computer draw the rest of the graph in. Or I can just use the absolute value symbols. Okay, and I press OK. And you can see how it would go through those points and all the ones in between. You get a sharp change of direction in an absolute value graph right here. A little bit weird for most of the graphs we look at. Most of them are curves of some shape or another. This is not curved at all. It is a sharp break right at the origin. Wrong page. The last graph we're going to look at is the graph of y equals 1 over x. This is a tricky little graph. It kind of depends on the fact that you know how fractions work. Okay, and I'll mention that as I go in here. So let me get this ready to go. Okay, so y equals 1 over x. Let's table of values. This table of values is going to get a little weird. When x is 0, 1 over 0 is undefined. You can't have a denominator of 0, so 0 is the only non-permissible value in this graph. So what you're actually going to get here is a vertical asymptote on the y-axis. Now again, if you haven't done asymptotes yet, if you don't know what an asymptote is, don't worry about it. Come back to this video in the future when you've seen them. Okay, I'm going to put an asymptote in here, and because I've got some nice color, I'm going to make it red. And like any asymptote, I'm going to make it dotted. Okay, so you can see there's an asymptote on the y-axis, right? When x is 1, 1 divided by 1 is 1. If x is 2, 1 divided by 2 is a half. When x is 6, and I'll show you why I'm jumping here, we get 1/6. Okay, so we get a point at 1, 1. At 2 comma a half, which is about there. Sorry for my, let's see if we can get that a little better. Well, it's not letting me put it in a perfect place. And at 6, we're at 1/6. Again, these dots aren't in a perfect place, but they're pretty good. As x gets larger, it's going to get smaller and smaller on the graph, but it's never going to hit 0. When you have an x of 1,000,000, so way out to the right, 1 over 1,000,000 is a very small value. It's 0.000 for a long time, 001. But it's not 0. It's not ever going to hit 0. It's actually bounded by a horizontal asymptote on the x-axis. So I'm going to quickly draw that in as well, or let the computer draw that in. Again, I'm going to go red with a dotted line. Okay, so there's our two asymptotes. The other question is, what happens to this graph in between 1 and 0? We got to fill this graph in right up to the asymptote. So I'm going to pick a weird value for x. I'm going to pick a half. When I get 1 divided by a half, if you remember dividing fractions means you invert and multiply by the bottom fraction. So I actually get 1 times 2 over 1, which is 2. If I have 1/6, the next value right in here somewhere, that will become 6. So at an x of a half, I get 2. And you kind of see the echoing of these values. At an x of a sixth, I get at an x of 1/6, I get 6, which gives me a point up there. So what shape does this make? I'll let the program show you in just a second. I'm going to go on to the negatives. Actually, I'll just leave those there. The negatives, we're going to get all the same values, but negative. Because 1 divided by -1 is -1. 1 divided by -2 is -1/2. Making the x value negative makes the y value negative in this function. So we get the same kind of points, but down here. -1, -1. -2, -1/2. Again, that point's not exactly in the right place. -6 gives me -1/6. -1/2 on the x, which is right here, gives me -2. Not quite in the right place. And -1/6 gives me -6. So we're going to let the computer draw this parent function now and take a look at what it looks like. You're going to see how far off my points are there from my shaky hand on this tablet. So y equals 1 over x. Okay, and I'm going to just graph that in black. And there's what you get. This curve bounded by the two asymptotes that exists at every single x value except for 0. It will never touch or cross the vertical asymptote. It will never touch or cross the horizontal asymptote. Okay, your teacher will take you through more what an asymptote is and the behavior of this. Again, this is meant just as a quick review of what the parent graph of 1 over x looks like. Most teachers are okay if you just put the point 1, 1 and then draw the graph bounded by the two asymptotes and the point -1, -1 and draw the graph bounded by the two asymptotes. So I hope this helps as a quick review of these functions, and thanks for watching the video.